Okay, next we'll look at simple distillation. Distillation is the process of separating the components or substances from a liquid mixture by selective boiling and condensation. By selective boiling and condensation. We know what boiling means. Heating water to 100 degrees Celsius, boiling, right? The process by which liquid changes to gas at 100 degrees Celsius. While condensation is simply the process by which a substance changes its state from the gaseous state to the liquid state. Gas to liquid is called condensation. Distillation is of two types. We have the simple distillation and we have the fractional distillation. The simple distillation, this method is best for separating a liquid from a solution. Separating a liquid from a solution. Let's take note of these differences in the definitions of these separation techniques. In a way, the concept is similar to evaporation, but in this case, the vapor is collected by condensation. For evaporation, the vapor disappears into the atmosphere, but in the case of a simple distillation, the vapor is collected by condensation. For example, if you want to separate water from a salt solution, simple distillation would be great for this. I think we have the diagram right here. I've seen it here. Okay, this is the whole process. This is the whole process. The first part, this part is the simple distillation, while the other part is, I think, fractional distillation. Fractional distillation. Fractional distillation. Okay, so for fractional distillation, fractional distillation is the separation of a mixture into its component parts. Don't get me wrong, for simple distillation, if you want to separate water from a salt solution, you can use evaporation. Yes, evaporation to dryness. We can use that, evaporation to dryness. And also you can also use a simple distillation method. There are methods you can use for recovering a salt from its solution. All right, from its solution containing water. You can use evaporation to dryness, but one of the best methods to use is the simple distillation. Simple distillation, in the sense that once the water evaporates, it can be collected by condensation. It can be collected, so having pure sample of the water can be collected by condensation. But for the evaporation process, the water escapes into the atmosphere. So fractional distillation, the separation of a mixture into its component parts or fractions. Chemical compounds are separated by heating them to a temperature at which one or more fractions of the mixture will vaporize. It uses distillation to fractionate. What I'm trying to say is this: similar to some simple distillation, fractional distillation is best for separating a solution of two miscible liquids. Miscible liquids are liquids that dissolve in each other. The fractional method takes advantage of the different boiling points of the two liquids. And one of the greatest example in which we employ fractional distillation is in the separation of petroleum fractions. Yes, petroleum fraction. It is employed in the petroleum industry very, very well. Fractional distillation to separate petroleum components, to separate petroleum mixture into its different components, and it makes use of their boiling points. The next, crystallization. Crystallization is the natural or artificial process by which a solid forms, where the atoms or molecules are highly organized into a structure known as a crystal, formation of crystal. Some of the ways by which crystals form are precipitating from a solution, freezing, or more rarely deposition directly from a gas. Attributes of the resulting crystal largely depend on the factors such as temperature, air pressure, and in the case of liquid crystals, time of fluid evaporation. So crystallization is just a separation technique in which at the later end, crystals are formed. Then we'll look at recrystallization. Recrystallization is a technique used to purify chemicals by dissolving both impurities and a compound in an appropriate solvent. Either the desired compound or impurities can be removed from the solution, leaving the other behind. So it's used for purification of chemicals, recrystallization. The magnetic separation is a process in which magnetically magnetically susceptible material is extracted from a mixture using a magnetic force. This separation technique can be useful in mining iron as it is attracted to a magnet. Magnetism is ideal for separating mixtures of two solids with one part having magnetic properties. Some metals like iron, nickel, and cobalt have metallic properties, while gold, silver, and aluminum do not. Magnetic elements are attracted to a magnet. That's just a short summary on magnetic separation using a magnetic separator. Okay, a magnetic separator. So sublimation, sublime. We know what sublimation simply means. The conversion of a substance from a solid state to a gaseous state without going through the liquid state. So when you convert a substance from a solid state directly to the gaseous state or vapor state without going through the liquid state, that is called sublimation. And we know examples of substances that sublime, like you have your normal camphor and you have iodine. These substances, they sublime. Sublimation is a transition of a substance directly from the solid to the gas phase without passing through the intermediate liquid phase. Sublimation is a technique used by chemists to purify compounds. A solid is typically placed in a sublimation apparatus and heated under vacuum. Under this reduced pressure, the solid volatilizes and condenses as a purified compound on a cooled surface, leaving a non-volatile residue of impurities behind. Once the heating ceases and the vacuum is removed, the purified compound may be collected from the cooling surface. We're going to see just a simple diagram to illustrate these analyses I've given. Okay, I think we have the diagram here. So that's the residue left behind. Dark green crystals of nickelocene, sublimed and freshly deposited. So that is the process of sublimation. It leaves back the crystals while the other ones goes into the gaseous state. So centrifugation, okay, rounding up version. Centrifugation is a technique which involves the application of centrifugal force to separate particles from a solution according to the size, the shape, the density, viscosity of the medium, and rotor speed. This process is used to separate two miscible substances, but also to analyze the hydrodynamic properties of macromolecules. More dense components of the mixture migrate away from the axis of the centrifuge, while less components of the mixture migrate towards the axis, that is, move to the center. Some move away, while some away from the centrifuge, while some move towards the centrifuge. Okay, chemists and biologists may increase the effective gravitational force on a test tube so as to more rapidly and completely cause the precipitate or the pellets to gather at the bottom of the tube using a test tube. So one of the places or one of the examples in which centrifugation is applied is when you deal with taking blood samples or checking the components of the blood. Yes, blood samples, they apply in hospitals and laboratories, they apply centrifugation processes. Okay, as we conclude, separating funnel. In this technique, two liquids that do not dissolve very well in each other, two immiscible liquids. Don't forget, fractional distillation is the opposite of this one. For fractional distillation, you are separating two miscible liquids. While separating funnel, two liquids that do not dissolve very well in each other can be separated by taking advantage of their unequal density. A mixture of oil and water, they are immiscible, can be separated by these techniques. So classification of separation techniques, the basis of separation and the separation technique. So on the basis of their size, we use filtration, Dialysis, okay, in biochemistry, dialysis is the process of separating molecules in solution by the difference in their rates of diffusion through a semi-permeable membrane. Then also you have that there. Then the mass or density, we have centrifugation. Then the change in physical state, we have distillation, we have sublimation, we have recrystallization. Then the change in chemical state, we have precipitation, the creation of a solid from a solution, precipitation. And those of us that did salt analysis in secondary school, we did all these things after testing the specimen given with either silver nitrate or one of those reagents given to us. What do we say? We say a deep blue precipitate is formed. Yes, a green precipitate is formed. A colorless precipitate is formed. Yes, and all those stuffs. Okay, so precipitation is the creation of a solid from a solution. When the reaction occurs in a liquid solution, the solid formed is called the precipitate. It's called the precipitate. Why? When we have partitioning between the phases, we use extraction, or we can also use chromatography. So thank you very much for your time. I'll send the questions regarding what we've done this evening. Thank you very much.